Alrighty, this video is to remind you that it's not always our fault. Sometimes our plants die because of natural disruptions to their ecosystem, not because of humans. It's going to be okay. As we know, our ecosystems are constantly being disrupted all the time. These can create short-term impacts, long-term impacts, but at the end of the day, it's going to affect the biome. Now, these events can be big, they can be small. We're going to start talking about some natural disruptions, though. And when we say natural disruptions, we're talking about nature made. Nature is the cause of these disruptions. We are not always the biggest disruptors, as I mentioned. And when these disruptions happens, the organisms that live in these biomes or in these ecosystems, they have three choices. They either have to adapt, they have to migrate to find a new biome, or they die and then become extinct. All right, so let's talk about what these big events are. First, natural climate change is going to be one of them. Come back to that later. It could be sea level changes or it could be glacier ice levels that are changing. Or we're going to separate all these other kind of temporal versions, these temporal changes, into three categories. They could be random, they could be episodic, or they could be periodic. Let's go into more detail. Periodic disruptions are cyclical. They're always going to come. They're quite predictable. We know that every 3 years we're going to get flooding. It's going to happen, El Nino, or it could be a hurricane that comes through. So quite predictable, but when this action happens, when this natural disaster happens, it does dramatically change the ecosystem. Episodic is a little different. These are less frequent, but they still recur. When we say less frequent, we're saying like thousands of years. Instead of every 3 years, thousands of years. So ice ages are a great example of this. It's going to happen a few thousand years. We'll get another one coming back. Very cyclical. So this is an example here. You can see that we're getting these very cyclical ice ages that happen in a pattern. So every, 100,000 years, we're going to go from low temperatures to high temperatures, back to low temperatures to high temperatures, back and forth and back and forth. It's a very cyclical pattern. So we can predict that we're probably going to enter into one. And even though this is cyclical, they're going to cause major changes and major disruptions that will force the biomes to also move. Now, random are the ones we cannot predict. They're rare, they're unpredictable. Example, impactor events, meteors colliding with Earth, or it could be a disease that spreads through nature. We can't predict these. They just happen randomly. Now, our largest, very important, largest disruptions are happening from climate change. Now, the current climate change is due to human activity. However, past climate changes are not always due to human activity. There are different parts of the Earth's cycles that can lead to this as well. Let's talk about them. So some causes of naturally occurring climate change include variation in solar output, a wobble in the Earth's axis, changes in ocean currents, and volcanic activity. All four of those can lead to increased temperatures or decreased temperatures. And those changes are going to drastically affect the biomes and where they're located. So forcing species to either die, migrate, or adapt. Now, the sun has been around for a good 5 billion years, and it'll probably be around for 5 billion future years. But we have found that the energy provided by the sun is not always consistent. So there was a time between 1645 and 1715 where the solar output was not consistent. It was actually reduced. So on the sun, we have all these little sunspots, and these sunspots are what create that energy, radiate out the energy that comes onto Earth. So unfortunately, during that period, there were very few sunspots. So you can see that we had very few sunspots during this time compared to the averages that we normally get, triggering a mini ice age. The wobble of the Earth's axis is another piece that has changed over the years. So this angle here, when that angle changes, different parts of the Earth receive a different percentage of that heat, and it's not spread out equally. So normally our North Pole is pointing at the star Polaris, but in the past it has actually pointed to the star Vega as well, and it's kind of tilted back and forth between the two. And as I mentioned, when it does that, different parts of Earth are going to receive a different distribution of heat. That different distribution is going to totally change the biomes. We could have what used to be a rainforest is now ending up more like a tundra because of that excess heat. Temperature is one of the main determining factors of what a biome becomes. Temperature and rainfall. So if that temperature changes, that means that our biome is going to change and species are going to have to adapt in return. Now, the other one is ocean currents. We haven't really talked about these yet, and we're going to go to a lot more detail this year. But our oceans are full of these gyres, whatever you want to call them. Our current ocean currents take water from the equator that's very hot, and they move it towards the poles. Then they take cold water from the poles and they move it down south towards the equator. This creates these gyres and these currents, which are extremely important in distributing that heat energy throughout the globe. Now, one concern right now is that we have a polar ice glacier kind of the top here and kind of blocking those currents. So the fear is, okay, once that melts, how is that going to affect our ocean currents? Now, our ocean currents, as I mentioned, they're moving energy. So if that energy is moved, our temperatures are going to shift. And if our temperatures shift throughout the climate and throughout the globe, then our biomes are going to shift. And if our biomes shift, then our species have three options. They're either going to adapt, they're going to migrate, or they're going to die. Now, this also relates to tectonic plates, because as we know, over time, over millions of years, our tectonic plates have also moved. So these tectonic plates may take something that's currently a desert and turn it eventually into a taiga, or take an area that's currently a tundra and turn it into a temperate grasslands. All of that is all possible based on the shift of those tectonic plates through the next hundreds of thousands of years. We can't forget, it's all based on the sun and where the sun is distributing that energy. So if a continent moves away from that energy, it's going to drastically change that biome, forcing species to adapt. All right, let's talk about volcanic activity. Interestingly enough, volcanic activity can cause a cool down and a warm up. So massive volcanic eruptions, putting tons of ash into the air, things like Krakatoa. And all this ash in the air is blocking the solar energy that's reaching the surface, causing the world to cool down. On the other hand, we can have the reverse happen. If we have multiple volcanoes erupting at the same time, that produces a lot of CO2 gas. And having excess greenhouse gases in our atmosphere will trap additional energy, leading to a warming of the climate. So both can happen with volcanic activity, either a cool down or a warm up. Now you're probably asking, Ms. Clark, how do we know all of this from the past? And there's some really cool stuff that we have been able to look at. By studying the distribution of fossil species and oxygen isotope ratios, we've been able to understand the movement of species in these past geological periods. So let's look at this. So as you've probably heard of before in middle school, fossil species are constantly moving. We've seen the biomes shift and the species move with them, causing those fossils to settle down when they eventually die. When the world was warmer, our tropical species were closer to the poles. However, during our glacial periods, some of these fossils associated with our taiga were found closer to the equator. We've seen this especially with the woolly mammoth, found very close down in Mexico where it really doesn't belong there. But that shows that we did have these changes of glacial periods. Now, many of us didn't know this, but there's actually two isotopes of oxygen. Oxygen 16 is definitely the most common. However, we also have this oxygen 18, which is a little bit more heavier because it has an additional 2 neutrons. Because oxygen 18 is heavier, it really can't evaporate very much and travel very far. It's going to condense so much faster than our oxygen 16 is. So let's kind of look how that has helped us over the years. So normally what happens is our water evaporates and then it travels up to the pole and then it condenses as snow. However, because that oxygen 18 is so heavy, it can't reach the poles. It's going to condense into liquid much earlier. So we're going to have water that's much more concentrated in oxygen 18 down here, where what's left over is the oxygen 16, which is reaching the top up here. So this snow up here is going to be full of oxygen 16 because it's a lot lighter. And then that water is going to melt. So we're going to have in the species that are consuming this water, we're going to find a lot more oxygen 16 than we are oxygen 18. So that's been a way for us to kind of track the movement of species throughout the past hundreds of thousands of years. I wanted to show you this because you can see we've had so many temperature changes over the last, 500 of millions of years before. Here we are right here. Here was this, our most recent ice age was happening right about here. That was about 20,000 years ago was when we had our most recent ice age. And if you look, like this is our temperature right now, but holy cow, it's been so much higher. We had many, many cycles of it being higher here. And then all the way back here, so much higher. This line right here, this is when our dinosaurs went extinct. So you can see the many different cycles that we've gone through since then. And these are all naturally occurring disruptions. All right, so we're going to talk about some of these ice ages. As I mentioned, we had one about 20,000 years ago. Ice ages are when we have continental glaciers. And these continental glaciers are when we have thousands of meters of ice on top of a continent. We are currently in a glacial period because we do have glaciers on Antarctica and Greenland that are covered with these continental glaciers. So we're currently in what we call a glacier period. We're on the way out of it at the moment, but we're in a glacial period in the moment. Now this is interesting because these glacial periods experience what we call a positive feedback loop. This is a massive idea for the AP exam. So I really want to kind of introduce it. We're going to look at many, many positive feedback loops in APES, but here's a great example of how these ice ages can build based on a positive feedback loop. Now we have this thing called albedo. This is not a word I think you need to know for the exam, but albedo is the light that is reflected when the sun hits snow and then reflects off again. Now, when that light reflects off, that means that less energy was absorbed by our planet. And when less energy was absorbed, that means the planet gets colder. And when the planet gets colder, our temperature drops, so we're going to get more snow. And when we have more snow, we're going to have more reflection, aka albedo, and more albedo causes the temperature drop again. And this keeps causing more and more and more and more change. This change causes more snow. The snow causes more snow and more snow. So it's just a continuous positive feedback loop. Now, as we mentioned, 20,000 years ago, we had that ice age, and much of the world's landmass was covered in these continental glaciers. However, as the ice sheets grow and shrink, as we saw they did, as those ice ages retreat, come back, retreat, That means the geographic positions of many of the biomes are also going to shift. And when those biomes shift, then the animals that live in them have to either migrate, adapt, or extinct. It's that same pattern over and over again. Anytime those biomes move, due to many, many different reasons, species have to adapt, migrate, or go extinct. Now, an additional thing is that when these continental glaciers grow or shrink, the sea level is going to change. So when they grow, our sea level is going to drop. So this is the area right here, 20,000 years ago, where we had our most recent ice age. And you can see how low our sea level is compared to where it is now. When that sea level drops so much, that's going to expose a ton of biomes and change them drastically. So let me show you what that looks like. So when you look at a map, all this area right outside, this is the United States here, it's what we call the continental shelf. If you're in a plane, it's like normally beautiful, kind of turquoisey waters, not very deep. There's a lot of life in here. However, when the sea level drops, this is going to go away and it's going to be exposed, leading to future succession, groups coming in and colonizing this new area. So the biome is going to completely disappear, or it's going to shift out here. All these marine biomes will shift because of those sea level drops. Then if the sea level rises, we'll have the same thing happening again. Now, the other thing that can happen when our glaciers grow, sea levels drop, is that land bridges form. This is extremely important in North America. When the sea level drops, land bridges can form between massive land areas. This is what happened between Asia and North America, which allowed migration to happen across from one continent to the other continent. 10,000 years ago, we saw humans migrate from Asia to the Americas, and unfortunately that then led to the extinction of animals that were on North America. But we have to keep that that's another natural disruption to a biome, is when these land bridges appear, new predators can move in. So things to consider. All right, long video, I apologize, but so exciting. And just think about my plant. I mean, I did not kill this. It's all based on a natural disruption, I'm sure. Not my fault.